Alrighty. Um. Oh, I forgot to ask you. Are you okay with music?
I love music.
Perfect. Okay. Alrighty. How are you? How do you prefer me to call you? Like
You can call me
Mike?
Mike.
Mike.
I
Okay.
always I always introduce myself very professionally as Mr. Michael McDonald, but once you get to know me, you're like, yeah, there's no way. This guy's a Mike.
Alrighty. Oh, we already have people in the chat. Hello from Raleigh. Hello.
Ooh. Mm.
Alrighty. Someone was waiting for us.
Yeah,
Awesome.
that is I know that guy.
Yeah, I know him too. Hi, Niket. All right, we're getting people super early. That's nice. I normally have to wait like 4 or 5 minutes. Awesome. Well, how are you, Mike?
I am doing all right. It is 9:30 Central, and normally I'm just trying to rip myself out of bed right now, but I'm like 3 cups of coffee in because naturally you need the energy for a Twitch stream, right?
Yep, yep, same. Yeah, I always say I'm not a morning person, so 10:30 for me is actually early, so I'm still like kind of a little bit asleep.
Yeah, I get that.
All right, we're getting a lot of people in the chat. Awesome. Hi, Kareem. Hi, Cigar. Hi, LinkedIn user, as always. Hi, Samuel. Alrighty, awesome. So let us know where are you joining from? What time is it for you? Have you already had coffee? Or are you going to sleep? Um, what's happening? All right. I have a tea here and I love this mug. It's like that's how I feel sometimes in the morning. So, all right. Hi, Ganesh. All right, cool. Oh, a very intriguing topic. Thanks for thinking to bring it up. Yeah. Thanks, Mike, for bringing it up.
Well, MuleSoft has needed an infrastructure guy for a while, in my opinion, because there's so many aspects of application development. Like apps run on something, right? So understanding the flows of the bits and bytes and everything is awesome, because at least from my perspective. But I grew up kind of in the infrastructure space, but we'll get into that in a little while.
Alrighty. Yeah, so we're getting people. That's nice. Hello from India. Awesome. Thank you for joining, Anesh. Really appreciate it. All right, so I guess we can get started.
Mhm.
So, Mike, can you talk about your journey in MuleSoft? How did you get here? What were you doing
Sure.
before?
Sure. All right. All right. So we're going to take it back a few years. My career technically started 20 years ago, which is a very sudden realization as of 9:33 Central Time, 2023. Uh, so I started at my college back in the day when they used to call full stack devs webmasters. And during that time, I was coding in PHP, Cold Fusion, and I was the Flash guy. I learned how to use Flash. I learned how to do keyframes and ActionScript and things like that. Then I ended up getting my job at Walgreens Corp, where I started actually as a Java dev, and then moved into a very primitive form of what we now call DevOps. At the time, it was just a bunch of Ant scripts and just a cron engine called Cruise Control. And then from there, I jumped over into the infrastructure team, or as I was told at the time, the dark side. From there, my job was actually to help manage and maintain all of the bits and bytes, every single thing that sat on the network at every single Walgreens store across the nation. So I want you to think like somewhere to the tune of 500 to 750,000 devices on a single network, more or less, that I had to kind of manage, maintain all the firmware, maintain all the configurations, etc. Which then took me to VMware, where I started as what's known as a solutions engineer, very similar to what I'm doing today, and then moved into what was known as the hands-on labs. My job there was to basically do DevOps, but exclusively with virtual hardware. So I would we'd run a set of scripts and everything, compose desktops, compose servers, compose application servers, things like that, and then spit them out into what were called pods. So a lot of API work, a lot of work against a lot of old SOAP, WSDL, SOA-based APIs. And then I ended up moving my way over into MuleSoft just because, well, I already knew APIs, I already knew these things. And I have to tell you personally that if I would have had the opportunity to use Mule at my last job doing that DevOps work with the pods and everything, I probably wouldn't be here today because I would have gotten so much more done. I'd have been like, I can't leave this empire behind. So, in short, everybody, using Mule will make you faster. It's spoken from a very bad dev.
Very, very bad dev. I don't think you're bad, but thank you. Thank you for sharing that. All right. Well, that sounds super exciting. So I guess we're all interested in the topic today because a lot of people have asked for more architecture stuff. So,
okay. All right.
Yeah.
Okay. Well, let's talk for a minute here. And Alex, tell me, what do you know about disaster recovery?
I don't know a lot, to be honest.
Okay. All right. That's fine. So I'm going to go ahead and just quick share a picture on my screen here. Let's do this presents. And I'm just a big fan of sharing the entire screen. So it just makes things easier for flopping through tabs and everything. So, bear with me when, the calendar pop-ups and everything show up. So we're going to pretend here for a minute that this is your architecture for your application environment, specifically a MuleHub or MuleSoft environment. We're talking Cloud Hub 2.0 because there's no point in focusing on Cloud Hub 1.0 in today's conversations. There are analogs to how we can do everything we're talking about in Cloud Hub 1.0, but right now, I'm a big fan of Cloud Hub 2.0. I like the way it's built out. I like the way it kind of auto grows and auto flexes with your work streams. I also like the higher level of security. We can get into that in a very later discussion. But so from a standpoint of connecting to your applications and your applications connecting to your own sources of truth, be it something like Salesforce or a database in your data center, something like that, you always start with your private space. Now, not everybody uses a private space, but for the sake of having privatized communications and things like that over the internet, we're going to talk about using a private space. So what we've done here is we've taken our private space and we've attached it to a transit gateway. Now, what we're doing is we're taking advantage of the way AWS and Mule's partnership allows for that constant intercommunication between AWS's backplane and our Cloud Hub spaces that are built out for our customers. And from there, you have connections either VPN based or something like that directly to your data center. And you'll have VPC attachments into other VPCs, places where you might be running Lambdas, places where you might be running, you might be holding S3 buckets, stuff like that. That's going to give you that ability to kind of privately get to and from your data without like a lot of, ruffle, kerfuffle, or any man in the middle attacks is what they're called. Although, Alex, tell me, should we be calling that person in the middle attacks these days?
Sure.
I don't know, right? So let's pretend this is your architecture. So the thing about this is that if anyone was paying attention, even just 2 days ago, we saw a pretty significant outage in AWS's US East 1. And now, to be fair, infrastructure is trying to make something wildly complicated incredibly easy. Like, that's the fundamental basis of every single thing that MuleSoft does. That's the fundamental basis of what AWS does, who we work with so closely. That's the fundamental basis of what my last company did at VMware. Those kinds of things are just taking very complex subjects and saying, how can we make that as easy as possible? How can I make it as easy as possible to host your application so you can just focus on getting business done, as opposed to trying to, magically make, other things happen. So naturally, you need to plan for outages in US East 1 or East 2 or West 1 or CA Central 1 in Canada or any of the 15 EU regions, things like that. So, understanding the architecture that you can develop over time is ultimately what's going to save us a ton of time and money. Let's talk about before I go into architecting things, let's talk about the two metrics that every business uses for disaster recovery: RPO, which is recovery point objective, and RTO. All right. So RPO is basically how much data can we lose over a period of time and still have a viable business. So if you're a business who has a, let's say, 1 hour outage, how much does that 1 hour outage cost you in terms of lack of data, lack of ability to actually see things? By the way, this is a seltzer water, not a beer. Get dry mouth when I talk a little so much. So RPO is the amount of data that you can lose. And so when one of my customers used to be one of the big three credit bureaus, and they were basically like, it was about $24 million for every second of data lost. So as I'm sure you can imagine, that's pretty untenable over a really quick period of time. So they couldn't afford any outages. So they had a very highly resilient operation. And so that's how you measure RPO, is how much data did we lose as a period of time, so 1 hour might be several petabytes, or it might be several megabytes if you're not doing much. And then you have what's known as RTO, which is recovery time objective. Now, that's just a measure of how long can we go to get back online? How long can we get everything going and getting everything back up? So realistically, if you want to think intelligently about DR, the idea is, let's focus on how can we minimize either RPO, minimize the amount of data lost in a degraded state, or RTO, minimize the amount of time that you're going to lose in that degraded state to get back up to full functionality. In today's demo, we're not really as worried about RPO and the way we're doing things. We're going to talk about some of those structures and some of those things, but we're not necessarily going to focus on how much data did we lose in that period of time. So with that, I'm going to show you a quick demo. We're going to show you the end result, and then we're going to kind of Tarantino it back to the very beginning. Does that sound good?
Sounds good.
Awesome. So we're going to start with the fact that I created a couple of Hello World apps, and I created them in my two private spaces. We're going to get rid of the other one so I can extend this out. And you'll see I have one Hello System API app in my primary private space, and one Hello System API app in my disaster recovery private space. Because of the way Cloud Hub 2.0 works, you can now have apps that are the same name. So this is really helpful for anybody who has always been frustrated with well, now I have to have app name -dr, app name -region 2, or whatever that is as part of your mechanism. This is going to make life a lot easier. And just to show off my two private spaces really quickly, you're going to see my primary is in US East 1. So yes, it was impacted by that outage 2 days ago, but my disaster recovery private space was running completely fine. Now, it's my understanding that no Twitch stream is truly complete without some code. So I'm going to show you guys this application I wrote. Super simple script. Let's see if we can't make it a little bigger here. That basically is what I call my global load balancer test. And so as we kind of click through here, basically what you're going to see here is we're just looking to see, hey, at what point does my application fail? So that's why I'm looking here. I'm grabbing the code from my curl, and then I'm saying, hey, if that code is ever greater than 299, basically something has moved. It's not okay. Really, I could have said 399. Probably would have been fine. We're just going to mark it as failed, and we're going to wait for it to come back online. And then as soon as we're healthy again, then we're going to go ahead and kill the session and report how long it took for that failover. So going back to it, right, how I have it set up, and I'll show you the Route 53 configuration here pretty quickly. Actually, I could do that right now. Let's just go to here. And we're just going to hop in Route 53. And if it takes more than 2 seconds to open Route 53, my attention span will be lost, and we'll just move on to, trust me, it's set up correctly. And we'll talk about the actual setup later. And for those of you who are kind of just hey, how does this all work? I know we're going to be sharing the Medium link later in this conversation, just so it's easier to follow. But so we know how to kind of look at everything. So I have my disaster recovery entry here, and I also have, what's the other name? I have primary. Yep. Oh, nope, it's not going to be disaster, and I need disaster or primary. And you'll notice that down in here, these are marked as what are known as CNAMEs. Um, for what it's worth, we'll do, the super fast DNS 101. DNS is how we take, human readable names and translate them to addresses. And there are two main type of records that we care about in the MuleSoft ecosystem. The first record is an A record, literally, brought to you by the letter A today, record. That is a record where, and I'll just do a quick, we'll just do a quick create so we can see it. An A record is when I create any sort of record and I point it directly to an IP. So what that means is basically, hey, listen, going to asdf.mulesoftplatform.com will definitely take us to Cloudflare, for example. And what else is important here, especially in disaster recovery scenarios, based on how we have this configured, is the TTL. So the TTL is basically a way of saying for a given DNS record, hey, I will exist at least for this many seconds. Come back and check on me after that period to see if I've changed. So when we're creating a record for disaster recovery, they're saying recommended values 60 to 60 seconds up to 2 days. I'm going to tell you that for your DR records very specifically, we want them even lower because you want to minimize that time to disaster recovery. And when using a global load balancer, it's very different from a normal load balancer. A normal load balancer basically just tells packets to go one way or another. A global load balancer is actually a manipulation of DNS. And we're saying, don't go to this A record or don't go to this canonical name, go to this A record instead during this time of failure. Speaking of canonical names, that's the next one that we're going to look at. So a CNAME is significantly different in that when you create your subdomain, it points to yet another record. So honestly, the benefit you get here is having CNAMEs of CNAMEs of CNAMEs of CNAMEs allows you to abstract away the actual implementation of any given project. And so that way you can then replace things under the covers with a new record that then becomes seamless to the end user. Alex, before I go forward, does this all make sense?
Yep, makes sense.
Awesome. People in the chat, does I can't help you with your voucher, but does anyone else actually have any questions about DNS before we kind of move forward?
I don't see anything yet.
All right, cool. Wanted to make sure, right? Because for some people who never have had to work with DNS, they wouldn't know the difference between an A record and a CNAME. So, these are important things to know when you're planning for disaster recovery. Awesome. Well, thank you. I appreciate that. I'm not even going to try to pronounce Prith WI7. I like that. So, what we've done here as well is under our global, which could have been, api.mulesoft.platform.com, we've set up what are known as failover records that utilize a health check to help us know how to kick over back and forth. Our script here is still running, happy as a clam, I'm hoping. Let's make sure I get another dot. Yeah, we did. All right, cool. And so, but when the health check itself fails, then we kick over to our failover record, which is just going to be a different canonical name. You'll notice it points to my disaster recovery environment. So again, our primary to our primary, our primary record to our primary environment, primary.mulesoft.com, and then similarly, failover to our failover. And then the health checks too, these guys are super important because you need to make sure they're fast. You need to make sure the TTLs on your records are very light. So I actually have them set to hilariously 1 second. I don't recommend that even for production deployments, but I wanted the demo not to take a minute. So, but what we're doing is we're actually just checking what I'm calling my health check URL, which is just one of my Hello System API endpoints in this case. So we could actually click into this app and stop it to simulate a full region outage in this case. In one of the nice things about how Cloud Hub 2.0 works while we're waiting for this guy to shut down, let's get this up here. Oh, so we already failed. So we're going to wait to come back online. This is where we're basically waiting for the DNS to do its failover. But one of the nice things about Cloud Hub 2.0 is that as you build your health check API out over time, you're actually going to have zero downtime, assuming perfect code or not bad code enough at least, so that way you have the opportunity to just kick over whenever you need to. And as you can see here, we are able to switch our data entry in 31 seconds. So that means our RTO, in our particular case, in an active passive scenario, was literally just 31 seconds. And it was basically by making sure that our health check was as fast of a request interval as possible. And now this is the maximum or the minimum request interval you can do in AWS. But if you're using like Cloudflare, or if you're using other like CDN style things like Akamai or something like that, you're gonna have the ability to cram that request interval down even more. Which with a health check API, you don't really care, because the whole point of this is just to check various aspects of your application. So we've shown the demo, we've shown a lot of this stuff. I've talked through a lot of different things, but let's get into the architecture, if you don't mind, about why we would set this up and how we would set this up. So in disaster recovery, there are basically three main models of how you might do things. And so we're going to start with the assumption that with disaster recovery, we're going to duplicate most aspects of our architecture. So I'm just going to pop this over here, and we're going to squeeze another one over here. And can I make this full screen without losing my... Yeah, awesome, cool. All right, so we've got our two environments here, but the fact is that we're not necessarily going to rely on the fact that we're going to have two data centers for just for the sake of posterity. And at least initially, we're not even going to assume that we have two VPCs. What we're going to do is what I like to call, minimum viable disaster recovery. So what we're going to do is we're going to point our other transit gateway from our other data center. So we're just going to change this from US East to West, and we have to change the IP. Real quick IP lesson here, kids on the call. You never want to overlap IPs. You never want to have the same set of IPs within a given, what I'm going to call, domain. So because this cloud could theoretically talk through some mechanism to this cloud, we need to make sure that they don't ever overlap each other. So what you'll see here is I have 65,565-ish addresses on this 172.18 subnet, and then I have another 65,000-ish IPs on this other one. None of them overlap each other. CIDR notation is another big long story that we can go into maybe on another stream, but I don't think we need to put everybody to sleep tonight. So it's important to note, though, that now that we have this disaster recovery environment set up, we don't have any mechanism at this exact second to agnostically route between them, which is why you saw kind of had CNAMEs on top of records on top of records. So if we look here, I'm going to use this Terminator to basically say, hey, CNAME primary, right? And similarly, I created the same thing over here where we did, instead of primary, I'm just going to call this DR because I don't want to type out all of disaster recovery. And so now we have our primary disaster recovery. And what's really nice about doing it this way is that if at some point in the future I have to swap out my disaster recovery environment entirely under the covers, I can do so in a very non-invasive way. And then at the very top, and we're going to use this little color thing because I like this one. We don't need that anymore. We're going to call this our primary CNAME, or in this case, what we called in my demo, global. And the thing about that is that this actually will conditionally point to either your primary or to your disaster recovery. And so just to show that we're not normally going to this one, we're going to dot line that guy. Okay, so Alex, as we kind of run through this, Can you see, just to make sure? Like, I need feedback because I crave attention from people. Um, can you see that I have, like one primary, and then we're kind of really clearly showing that you never really connect to that disaster recovery until you absolutely have to.
Yeah, makes sense.
Awesome, cool. So now what we have is what I would call active cold, right? Your applications aren't running, your private space is set up, but nothing's really going through it, and you have your networking configuration all set up, but again, nothing's really happening here. And just for completeness, right? Like, your connection between your transit gateway should either be a direct connect or a VPN. Again, like, rabbit hole upon rabbit hole. We could go into the difference of why you would pick one or the other, but for now, I'm just gonna say it could be either into your data center, because we're just gonna say, hey, listen, at bare minimum, we still want our apps to run. If we lost US East 1, we might lose this entire VPC down here that is also in US East 1. And we'll get into why that is and why it has to be in US East 1 in a little bit. But in an active cold scenario, you might not want to take that risk of trying to figure out how to replicate traffic and everything across VPCs. You're just like, nope, I just need it to just work. So right now, we're just going to be at the absolute bare minimum. Nothing's running, nothing's sitting there in West 1. Everything's running in East 1, and the world is as happy as it can be. So this is, again, basically what I would call active cold. Now, that is what I'll call, the crawl part of the scenario. We have gotten to a situation where, hey, if we have a failure, we can at least get our apps back up. We have everything going. And, in a failover scenario, so long as I can still get to my data center, and maybe if I'm lucky, I can still get to my VPC, because just like 2 days ago, that US East 1 outage was not a full outage. It was just various services. So I might still actually be able to use RDS. I might still actually be able to use my EC2 instances, things like that. Goodness gracious, I'm starting to lose my mouth. So in that scenario, let's pretend, right? We're all good. Everything's good. So when we do draw that big red X through this side, which I don't know how to do very easily on Lucid at the moment, we're in a situation where, hey, we can at least still function. All of your traffic can route through the data center, over to this VPC if it has to, back through, etc. And you're like, well, Mike, that puts us in kind of a risky scenario. So you're absolutely right. So, whenever I have an API over here running, and we're just going to do, API 1 up, and we might have in a cold scenario, right? Like, it'll be down. You're like, Mike, that's great, but like, I happen to know that if I have like 35 apps over in my disaster recovery space and I'm doing active cold, that means I got to boot everything up, every single thing up in that disaster recovery environment all at the same time. That could take, like 10, 15 minutes. That's an untenable amount of outage. And to that, I say, you're absolutely right. And you should never, ever run an active cold. That's a Mike McDonald opinion, right? But if you're in a scenario where you're like, no, I need to actually, I want to do warm standby, right? Or passive, right? So we'll change this to API 1, right? That's going to be up this entire time. And now in this scenario, if you have an outage on this side, as we saw, we can shrink it down to about 31 seconds or less for our failover into our disaster recovery environment. Again, assuming RDS and everything is still running here, your connection to your data center is still set, everything's good. People are less unhappy than they could be. But then it's also going to continue to just naturally evolve. And most of the evolution is actually going to happen down here on this side of the overall chart. So at some point, we're going to start talking about, well, the most cost-effective way to start actually building out redundancy in your plan is, well, okay, let's talk about VPC replication. All right, let's talk about how do we get our things from US East 1 to US West 1. So what we do is we build our connectivity between this transit gateway and the VPC within its region. Not a lot of people know this, but you cannot do a direct connection from a VPC in West 1 to a transit gateway in East 1. You have to do what's called a transit gateway peering. So we're going to do that right now is we're going to build this peering. I'm just going to type in the word peer so we don't forget what it is. And so what happens now is that if traffic needs to go between this VPC and West 1, it will come through this transit gateway, down and through the peer, through this transit gateway, and into this VPC. This is fantastic because if I have a situation where I have a database over here and I want to do a replication to that same kind of database over here, let me zoom back in just a little. Oop, too much. All right, we're not going to fight with that. And we're trying to replicate to this database over here. Now I have an incredibly high speed AWS to AWS private connectivity situation where I no longer have to worry. Actually, I want to zoom back to time. That was not what I was aiming for. There we go. Right, back down. Now we have a situation where we can actually use, multi-gig throughput between these two databases. Now, speed of light still applies. The minimum amount of time it's going to be between US East 1 and US West 1 is something to the tune of 500-600 milliseconds. So keep that in mind as you're looking at how you build out your disaster recovery, that if you can't afford 500 to 600 milliseconds of downtime, maybe going across the entire country for your disaster recovery strategy is not the hottest idea on the planet. But what we've done here now is we've been able to actually just maintain the data center, ironically, as the only real source of failure. These APIs are up, and what we probably end up doing is putting, more CNAMEs and more load balancers at various points in here. So that way your database is actually behind a CNAME as well. So that way you actually have failover in the same way as you have up here. This is going to be a repeatable model all over the place, where you're going to basically have that level of abstraction that you're constantly aiming for as you go through each layer of your infrastructure. What's awesome about doing it this way, as opposed to using maybe a direct load balancer, which is a much faster failover, let's be clear, it's a much faster failover, but it gives you the ability to dynamically switch which database is taking and accepting all your connections all the time. Pro tip for all you Mule developers, by the way, make sure you have a reconnection strategy in your app. So when you have a regional outage, because for example, this API will be pointed to this database day one, unless you do some parameterization or anything like that, and then would dynamically flip over to this database, it would have to reconnect after losing access to this one. So just something to think about as you're kind of going through this, like how do you always want the west side to talk to just the west side? We can do that. Or do you want west and east to kind of, talk to whichever one's the most active database? However you want to plan that, that's kind of up to you and your business, but something to think about as you're planning through disaster recovery. So, finally, if we're at active passive right now, we could even be borderline active, except for we've not established any replication. So we're just going to do that quickly with some arrows here. Our database replicate to each other, right? We're using Golden Gate or some other sort of replication technology, and it all flows through that transit gateway peer through those attachments. And so now we actually have a situation where we actually could, rather than keeping this guy as a dotted line and as a failover point, we actually could start going, active, where instead of being disaster recovery, we're actually, primary 1 and primary 2. And I should have changed that to disaster recovery a long time ago as we were kind of going through this, but, live and everything, right? So now in an active scenario, as we've kind of built this out over time, we actually have the ability to, instead of using a health check, well, we would still use health checks because we still need to know whether or not to ever route traffic to one side or another. But now in Route 53, we start talking about traffic policies, which I've never created, so we're not going to do that today. But like, you have the ability to start going through your primary or your secondary and using weights and things like that to try to figure out, hey, which route do I want to actually force traffic to and from? And again, this is all Amazon focused because I have access to Amazon. you can do these exact same kinds of things directly in your data center. An F5 load balancer will do this. So will a Palo Alto most likely, right? Like there are lots of different tools out there that kind of can accomplish all of these things. It really comes down to what's going to feed your need as a business to kind of make sure you can maximize your or minimize your RTO and RPO realistically. And if I were some sort of a data center architect or maybe even a smart person every now and then, I would never trust a single data center. I would always, if I had to have 2 data centers, I would. But realistically, we live in a modern cloud world. So what is the real answer here? Your disaster recovery is a replication to AWS. And you'll notice it's only a one-way line. And we're going to pull that down so that way. There we go. Slightly less ugly. And the reason is because why would you build out 2 data centers? Most of the time, they usually cost billions and billions of dollars, when realistically, your replication into AWS will give you the same thing, and your data center is the only active passive part of this whole thing, where then as soon as your data center goes down, you already have warm, live, replicated data in that VPC, where it's just the same kind of failover, again, using some smart CNAMEs or using a smart load balancer to kind of just cut you over into an active scenario. So wow, we've just literally taken the walk from active cold, or just a single active data center, all the way into active, and we did it, I think, in about 20 minutes. What are some other configurations that some of you, if you want to put it out in the comments, I'd love to see what are some other configurations you've seen in your own environments, or what other things have you seen, or what other questions have you had where you're like, why would we do it this way versus this way? I'm going to call that out right now. Start throwing them in there. And in the meantime, I'm going to start going through maybe a little bit more on some of the Route 53 stuff and some of the actual attachment stuff, and like why we did things the way we did. Does that sound good?
Yep, sounds good.
Awesome, cool. So let's go back into our private spaces here. And so, this is actually a really good point to talk about here. All of these various records here in these private spaces. So we've already kind of covered, a CIDR block, in this case, a /24. That was not what I meant to click on. A /24, that's 255 addresses. We've established that a /16 is something like 65,000 addresses. But realistically, let's talk about these targets, because these targets are going to be super important for how you make sure you route the data correctly throughout your application. So with that, we're going to use one of my favorite tools in the world is the terminal, and we're going to do a quick lookup here. So if you don't mind that things route to and from through the internet, we use a tool. I use NSLookup all the time, and you notice here I'm getting what are known as public IPs. So public IP means your traffic is always going to have to go through the internet at some point. That's just how the rules work. That's how everything kind of functions and focuses and everything. But if we put the word internal dash in front of it, now all of a sudden we're getting those IPs that are within that CIDR range that I've established here as part of this. So what it's saying is that when you're hitting that primary target on any of your private spaces, you have the ability to route through an internal mechanism, which means that it doesn't leave the transit gateway. It doesn't go outside through the internet gateway. It stays well within your network, meaning it stays constantly within the control of your stuff. This is I would recommend this approach for anyone doing any kind of replication traffic, or if you're calling to any of your backend systems. Do everything as internally as possible, because it's going to be the most secure as possible with the least amount of work as possible. What you're doing is you're just letting the network work for you. But what you'll see here too is we have these outbound and inbound static IPs. And this is for scenarios where you're going to have situations that are, you're connecting to a third-party vendor. And that third party vendor is like, well, how do I know it's you? And you can say, hey, listen, when you call into me, these are the only IPs you can call. And if I call out to you, these are the only IPs you will see. And what that does is it allows us to create what's called an allow list, which means that now we can kind of create sort of a virtual private, interconnectivity space. And it's not actually a VPN. Don't conflate those, please. I realized my mistake as I said that. But it's a way of saying, like, I'm not going to accept any traffic that doesn't come from a third-party vendor. I'm not going to accept any traffic that doesn't come from here that is established as you, whoever you are. And simultaneously, I'm never going to call out to anything except for these IPs. And the reason we use IPs is because, as you've seen with DNS, we can create a DNS out of anything. So, if I wanted to translate in my own Route 53, let's go back to hosted zones. This is kind of semi-turned into a security discussion, just, totally due to stream of consciousness. But it's very easy to create, a lot of fun. So if I created, google.mulesoftplatform.com, I could easily just translate that to google.com, and realistically, there's no one to stop me. And so as soon as that record's done, then I'm going to have the ability to basically just go to, google.mulesoftplatform.com. And if we just ignore the certs, it could theoretically just take us to google.com. Obviously, there's some screw up there. But we are hitting Google services, so we're not going to do that anymore. Google will probably find a way to kick me off of the internet if I continue to do something silly like that. So, long story short is having a way of truly securing your identity is really important. So, just throwing that one out there. So you'll notice that we don't have any private inbound and private outbound static IPs, and that is just due to the fact that we don't. Everything inside of our VPCs is DHCP, dynamic connectivity, that sort of thing. So we're always focused on how we do everything from an internal only perspective. So I've kind of ripped through a whole lot of things here in about 45 minutes. I haven't seen any questions, so either I'm really good or we've lost everyone's attention and eyes have glazed over.
I think you're just really good. I see people. People are here.
In short, I guess thank you. One of the things I would call out, in building out a disaster recovery scenario is always pay attention to, how can I take little small things? How can I use CNAMEs? How can I use, how can I basically use ways of having virtual DNS records and utilizing things like, Route 53's health checks and traffic policies to help me very quickly switch between my active and my passive scenarios. And, for what it's worth too, this is the most important thing. Always test your DR. And I can't stress that one enough. When I used to work for an infrastructure company, the big focus on disaster recovery was everyone did their DR test once a year, and it was always a scramble. Hey, Alex, do you travel a lot?
A little bit.
little bit. Going to Pearson Airport's a nightmare, isn't it?
Yeah.
And it's mostly because you walk in the door, everyone's kind of scrambling around, you don't always know exactly where to go, right?
Yep.
So similarly, if you were the kind of person who was focused on, hey, I'm going to do disaster recovery once a month, all of a sudden, you now know every single step, every single thing you're doing, because you do it regularly enough that it doesn't feel uncomfortable when you have to do it. You don't have to bust out the checklist anymore. This is the checklist. Document your checklist, everybody. So similarly, having a set focus on, hey, listen, at any given point, if this is my health check API, and this is what I'm using as my failover point, I need to just do this once a month, every other week, right? Like if you're active, it should be like every other week. It should almost be every other day. There are big companies like Netflix who has, tools like Chaos Monkey and things like that actively go out and randomly delete and stop services across all of their platform. Like there's no single system that Chaos Monkey doesn't touch, but it does it to validate resiliency. So, and that's the biggest thing here is that, it's unfortunately our job as the developers to basically guarantee a certain amount of resiliency, because, if we can't do our job, and like now, admittedly, I say as the developers, we're all kind of in this together. Your infrastructure guys are doing what they're doing, the developer people are doing what they're doing, but they need to ultimately come together to make this kind of thing a reality collectively, because, I'll tell you straight up, infrastructure people have no idea what applications do. People like me who spent their life as a webmaster or full stack dev, whatever that is, and people like some of the developers I have on this stream who've never actually touched a server in their life. Like, you guys gotta come together to make sure that something like DR can work. And don't be afraid to get. I'm going to be very careful in using the word clever, because every single time I try to do something clever, it almost always fails. But having a clear understanding of how to focus on the end goal, and how to like simplify that cutover. For example, like I said, using these CNAMEs here, absolutely not required. We could go back into Route 53 right now and just simply go into each of these global connections and replace this primary value with something else, right? I could replace it with the actual target endpoint here, this actual name. But the problem is that at some point, I'm going to lose that disaster recovery, or that primary VPC. I'm going to lose that space. This may go away. And so having kind of an abstract way of saying, okay, cool, well, the new primary is now going to be this new private space. You have a failover, a cutover mechanism. We also can even just start converting these from simple CNAME records into failover, a failover, a failover, a failover records. So now all of a sudden you have, DR to your DR to your DR to your DR. And all of a sudden you have this big long stretch of all of these different things where if you have a failure, okay, cool. So this private space is gone. We're going to go to this private space. Oh, this database is gone. Well, we're just going to jump over to this database, but you haven't changed anything in the application code, right? Abstraction is your friend, and the ability to kind of drive forward a conversation around like, hey, listen, now let's go back to my, let's not call this global. Let's call this, API, and that will go to primary 1 or primary 2. And then we'll come down here and we'll create a CNAME again. And this will be, DB1. And we call that one DB2. And the fundamental call between the two of them would be just, db.softplatform.com, just like that kind of thing. It looks terrible, but bear with me, right? The idea, though, is that at any point, you can fork your road without having to change your code. That's quoted. That's copyright Mike McDonald, 2023. You can fork the road without having to change your code. And realistically, the win here is, again, you have that ability to just start adjusting things under the covers, allow your app to use this reconnection strategy to just reconnect and just get back to business. And it's going to basically save you a ton of time. It's going to save you a ton of money. And the last time I checked, you're not capped on the number of DNS records you're allowed to have in your server, especially if you're using a bind or if you're using something like I can't remember the name of the major company that most businesses use, but Infoblox, that's it. So use them to your advantage, and create abstraction records, create this ability to just have this dynamic failover whenever you can. And yes, a lot of this is cloud dreams, right? But if you don't start somewhere, you're never really going to get anywhere. If that makes any sense, everything starts with a vision. The iPhone, the iPod, Android phones, the laptop we're working on, Twitch, etc. And eventually the implementation comes. So if you start with this vision of this grand DR strategy, maybe you'll just get that much closer to the 1 minute failover that the business really wants, as opposed to the 10-minute failover that the business is willing to pay for, that kind of thing. So with that, I'm just going to have to keep vamping if we're going to fill up another 10 minutes. So, I haven't seen any questions, but I would love to hear from people in the audience. I'd love to know what you're thinking. I'd love to know what's going on. Either that, or we can just, listen to this. This is really good music, Alex, by the way. I am really digging this.
Yeah. I mean, I don't know what it is. It's just here, but
yeah, it's fantastic.
Cool. Yeah, I don't see anything in the chat either. So if you still have stuff to go through, you can go do that. That's fine.
Yeah, well, and that's kind of what I mean. Like at this point, like without any feedback from people, I didn't want to start going down. But hey, we can get into cider math. We can get into different topologies of how we might do things. Kind of up to anybody. But I suppose if we were gonna really extend this out, which we can make this a fun, just unexpected side exercise. So that is an awesome question. That is a fantastic question. No, it is not, because instead of using a private space, I can actually use this exact same architecture with with CloudHub 1 VPCs and dedicated load balancers. So similarly, let's go through a little bit of that exercise because it's gonna buy us a little bit of time. So I'm just gonna create a new tab here so we can start kind of with fresh paint. But I'm then gonna almost immediately paste everything into place. So I suppose that was kind of a waste, but I didn't want to lose our original diagram. Oh, come on, let's fit to content. All right, so instead of a target, we're gonna change this to to a DLB, right? Now, for those of you who are not familiar with our DLB, that is a dedicated load balancer. Basically what it is it's a reverse proxy that sits at the front of any of your VPCs. And instead of a private space, we're gonna say it's a CloudHub 1.0, primary one, VPC. On that, nothing else has changed, okay? And we're gonna do the same thing on this side, DLB, VPC, and CloudHub 1.0. Because one of the nice things about the dedicated load balancer that's built into CloudHub 1.0 is you could set up basically the exact same function. And one could argue, and for the record, this is not the reality situation, but one could very easily argue that the target at the front of a CloudHub 2.0 space is kind of just exactly like a DLB. It has a lot of the same functionality, has a lot of the same features. There's a lot more going on under the covers. We don't need to get into that back-end stuff, but absolutely works the same way. And because, and we'll go ahead and go to load balancers, and we'll look at my my load balancer I have here. Because you can do things like an allow list CIDR and things like that, I can easily restrict all traffic to anything that goes through that DLB just by saying, all right, cool, we're going to do only the RFC 1918 subnet. So that's a 172.16.12. We'll add another one, 192.168. 168.00/16. And the final last one is, 10.0.0.0/8. So for what it's worth, right? Here's a good way to think about it. 65,000 IPs within this range. I think it's something like 1.2 million IPs, and this is definitely 2 million IP or 2 billion IPs. I could have that completely wrong, or 2 million IPs. I could have that completely wrong. It is still early in the morning, isn't that right, Alex? Okay, so we've got some questions here. All right, how to support 1 to 3 gigs of file data, which is DZIP files on less than 1 to 2 vCore. So that's not architecture, but I'm going to answer that because, hey, let's rock and roll, man. I'm ready for this sort of thing. So honestly, what you have to do is you have to do streaming. You cannot handle that file in a full chunk. You have to break it down into a stream and then bust it up into places, into other places. So that's the only way you can kind of tackle it that way, to keep everything within that smaller heap size. Actually, I believe it was the very last session that I was on, at least, where we had Chuck Hurstis on doing the binary files streams. That was pretty good. There's another demo that we could probably show, and I can't show it today because I don't have it set up at all. But like I did a 45 gig file on exactly on a 0.2 vCore machine. So that's something that we can talk about in a little bit. That was entirely a CSV file. It was a gzip whatever, but like it was designed to go for infinite number size. Okay, Justin James, great question. How about control plane on MuleSoft GovCloud and runtime on premises? So let's go back to our little game here. Okay, GovCloud, first off, GovCloud is Cloud Hub 1.0. So you can do a lot of these same things with 1.0. I do know there's a lot of different rules with GovCloud that I am honestly not wildly familiar with, but you know, the big focus there is, hey, keep your communication privatized, keep it secure, keep it all tight-knit. You can still do all of this DNS failover stuff across dedicated load balancers on either side. That's going to be fairly easy. Now, runtime on premises. That's where this gets to be very fun, because that's where you start talking about, how do I do my own data center failover design? Now you have several different options. Now, within the AWS data centers, and we're going to go ahead and just draw one big cloud, and we're going to find a way to do this, hopefully creatively, and in under 4 minutes. That'll be the hard part. So in this cloud, we have what are called availability zones. Now, what is an availability zone? An availability zone is a way that these clouds are split, and we're trying to do this cleverly, clever being the keyword again, as possible, into separate network infrastructure, separate power infrastructure, and separate storage infrastructure. So that means that if at any point we have a complete cratering of say AZ2 in US East 1, which is, US East 1, US East or AZ1 and AZ3 are still very active, doing exactly what they were supposed to do. And because of the way MuleSoft works, we're able to instantly kick off new versions of your application in other AZs as one of those AZs dies. So that means if you had an application here, it obviously died for whatever reason. So we're going to send that to back. It's behind our little send item backward. It's behind our little X. It's a dead app, right? But I can actually still take that app, and we can automatically spin up a new version of it over here. So that makes life significantly easier from a standpoint of that all happens automatically for you. Now, similarly as to before, right? Like we lost everything. So in your own data center, going back to the main point here with the 2 minutes we have, in your own data center, you want to validate, do we have availability zones? Okay? Because honestly, building a new data center is usually to the tune of billions of dollars, not millions, billions of dollars. So what that means is that you're going to want to probably spin up your individual runtime, which is just going to be RT, and allow it to be clustered across your various availability zones within your own data center. And so MuleSoft runtime clustering uses a tool called Hazelcast, and it is a unicast stream that kind of fires back and forth between the two. I'm fairly positive you can do it across layer 3 boundaries, but that is something I'd have to triple check on, which is what would be necessary to do in a availability zone configuration, explicitly in this scenario. In fact, that's actually what happens in EC2 behind the scenes. Your big /16-sider or big /24-sider is actually split into multiple subnets, one subnet per availability zone. And we divide it as evenly as we can. Sometimes that's not necessarily possible. So a /24 would actually be split into 4/25s, 2/25s. So 4/27s or 26s. Sorry, gosh, math is hard. 4/26s. But realistically, there's only 3 AZs. So you're going to get 3 out of your 4, and then that fourth one's going to kind of kick in when we lose something as we spin up a new subnet as things go down, et cetera. Well, something to figure out later. Like that's all implementation stuff. But long story short, we got your back. Don't worry. You're not losing just magically, one quarter of your IPs at any point. So that'd be the best way to do it in single data center. If you had a multi-data center scenario, honestly, I would do 2 clusters. Let's get this moved over here. I would do 2 clusters and then have my CI/CD deploy to both clusters. And the reason I would do it that way is because then you can manage each cluster independently of each other. So that way you actually have kind of a failover scenario and you have an upgrade path. I'm going to upgrade the left side while the right side runs. And then as soon as the left side's done, we're going to quick do a canary test. Great, everything's good. Cut over to that side and now upgrade the other side. That same kind of thing can actually work kind of ubiquitously across all your Cloud Hub stuff if you want to start using traffic policies or things like that as you kind of cross your streams. With that, I have absolutely exhausted time. Alex, is there anything else I need to do or anything else we should see, or what can I do? I'm excited. This is fun. Why didn't anyone ever tell me about this?
Well, Srini did.
Oh, fair point.
I don't see any more questions, but
All
I'm gonna go ahead and share your Medium blog so people can check that out. Maybe you can let us know what they're gonna find there. All right.
Yeah, and this is a step-by-step, by the way, of our active passive stream. I strongly recommend anybody who is interested in this kind of stuff, reach out to me on LinkedIn to whatever it's going to take. Let's make this, as easy and as fun for everybody as possible. That way we can, drive forward, like kind of an actual active world, maybe eventually, fingers crossed. No more downtime. That's the goal.
Great session. Thank you.
Thank you.
All right. Well, that was awesome. I learned a lot, and I'm not an architect, so that's good.
And we could do thousands more of these, right? Like I enjoy being wildly pedantic over subjects that nobody cares about.
Sounds good. Yeah, for sure. Let me know if you want to do another stream.
Mm-hmm.
In the meantime, for the people watching, remember to follow us on twitch.tv/MuleSoft_community, because there we have all of our previous recordings. If you missed all of this talk from the beginning, you can just go there and watch it from the start. You can also see our schedule to see when we are going to be live, and you can get notifications as soon as we come live so you never miss us. So yeah, that's all. Another great session. Thank you.
Yeah, thank you.
Alrighty, I guess that's all then. Thank you so much, Mike. I really appreciate your time.
Yeah, no problem. We'll catch you on the next one.
Alrighty.
All right, we'll see you later.
Bye-bye.
Bye.